Good afternoon. I'm Shankar Shastri, the Dean of Engineering, and it's my pleasure to welcome you to the the top-level lecture series, the Regents Lecture series for this fall, and to introduce our distinguished visitor, Dr. Paul Jacobs. I'm delighted to see so many Berkeley students in the audience. I know that many of you, particularly our first-year students, are taking part in a campus-wide conversation about technological advancement as part of Berkeley's On the Same Page program. In this year's program, incoming students are reading Turing's Cathedral by historian George Dyson, which tells the story of the birth of the computer age after World War II. And there may even still be a few copies outside, but I think they may be gone by this time. In a moment, when we hear from Paul Jacobs, you'll be able to appreciate how much the digital universe has expanded since Alan Turing's time. I'm also honored to welcome the Berkeley Engineering alumni and members of our Dean Society who are joining us today. The loyalty and support of our alumni and other friends plays a key role in advancing the Berkeley Engineering mission, which is to educate leaders, create knowledge, and serve society. I'd especially like to welcome all of you watching the program online. We hope that you will continue the conversation and follow us on Twitter using hashtag Regents Lecture or the hashtag Paul Jacobs, or by leaving a comment on the Facebook event page. Let me thank our student co-sponsors who have helped with today's event, the Berkeley chapter of the Society of Women Engineers, SWE, and Pioneers in Berkeley Engineering, PI. Thanks to both of these groups for their great work. And if you can identify yourselves. Each year, the Regents Lecture program brings an eminent visitor to the Berkeley campus, an individual who has made a lasting mark on society in fields ranging from the literary arts and scientific exploration to technological innovation. Previous Regents lecturers have featured visitors of such caliber as astronaut Sally Ride, Supreme Court Justice Sandra Day O'Connor, Wikipedia founder Jimmy Wales, author Toni Morrison, and futurist Stuart Brand. We are deeply honored to add the name and stature of Paul Jacobs to this illustrious roster of Regents lecturers. In my role as Dean of Engineering, it really has been my privilege to meet many powerful minds and leaders from around the world. Few can rival Paul Jacobs' vision and reputation for success as the chairman and CEO of Qualcomm. Paul's achievements, both as a technology innovator and as a global citizen, are a source of tremendous pride for all of us at Berkeley. Berkeley Engineering is understandably proud to claim Paul as one of our most distinguished alumni. He earned 3 degrees in electrical engineering and computer science here. And, whenever we have surveys of CEOs, it really helps to have 3 degrees from Paul counted in the... We'd be ahead of MIT. Get another one. Very good. We're also very grateful to have Paul's leadership as the chair of the College of Engineering's advisory board. Paul and his wife, Stacy, who's also a Cal alumna, holds multiple degrees from Berkeley, have expressed their loyalty and thanks to Berkeley in numerous and transformative ways. Currently, Paul and Stacy are co-chairs of the campus-wide campaign for Berkeley, which will close this year under Paul and Stacy's leadership after meeting an astounding goal of $3 billion. I think this is really a big number, and thanks to it. How many zeros? I'd like to take a moment to thank Paul and Stacy for their own magnificent commitment to Berkeley's campaign, a gift to establish the Jacobs Institute for Design Innovation. This new institute, now underway, will transform engineering education and indeed more broadly education across the campus by infusing an emphasis on hands-on design. So thank you very much, Paul and Stacy. Paul began his career at Qualcomm finding innovative ways to improve the performance of cell phone chips. He holds more than 45 patents for his groundbreaking inventions in wireless technology and is a recognized global leader in the field of mobile communications. Important developments that began under his direction include the first Palm OS-based smartphone, adding GPS capabilities to mobile phones, the Brew system, which enables over-the-air downloading of applications, QChat, a voice-over IP push-to-talk system, and Mirasol, an advanced reflective display technology. Now, as CEO and chairman of the board, Paul is extending the reach of wireless even further into services that enable us to transact business, teach our children, respond to emergencies, and monitor our health. These innovations are making a huge impact all over the world in both developed and in developing regions. And actually, the USAID administrator, Rajiv Shah, has said that he knows of no invention that has contributed more to the advancement for pulling people out of poverty than cell phones and wireless. And, for somebody who, for whom food and water and global health is so big, for him to single out wireless is really a huge statement. So please join me in what I'm sure is going to be a great treat in welcoming Paul. There's two chairs.
I love being at Cal. It's a great place to come back to. I love being on campus. I was telling Shankar I walked into Corey Hall and that smell. I graduated a long time ago. That smell is still here. There's something to it. I am sure you guys know who Qualcomm is because we have a cafe and a stadium. And but just quickly, I suspect you all know this, but we started in 1985, and it was basically started 7 people. My father was the key person who helped start the company, and now we've grown to be the #1 supplier of wireless chipsets. And because there's so many devices, so many smartphones and cell phones out there, it means that we're also the #1 shipping graphics chips and ship a lot of microprocessors and power management and radio chips. So while we started out as a company that really understood, the radio technology, we've really grown as the whole market's grown. We're fabless, which means that while we supply the chips, we're really all about intellectual property, and we create the designs in San Diego and in places around the world, but half of our employees are in San Diego still. And then they're manufactured in factories and in fabs around the world. #1 is in Taiwan with TSMC. But if you think about it, really we're creating intellectual property, we're creating ideas, and so the company is really not about a lot of capital expenditure. It's really about people and their ideas. And so the #1 thing that we care about in the company is to make sure that those people have a great place to work, they have the best equipment, they have great people to work with, and they have incredible opportunities. So the opportunity that we've been able to be part of is mobile, and it's really no hype to say that this is humanity's largest technology platform, and there's 6.6 billion connections out there in the world. Now, that's not the number of people. Their estimates are something like 3.3 billion people that are actually using it. But even within that, there's like it sounds like I'm 6.6, 3.3, 2.2, but anyways, the numbers are something like this, of mobile broadband users. So that's how most people are getting on the internet around the world, and that's pretty cool. And you find that mobile is now in places where they don't have things like running water, electricity. People actually have to go places to get their phone charged and then go back to where they live. There's more cell phones than toothbrushes. If you think about it, it's probably good that people have cell phones so they don't have to have face-to-face conversations if they have never brushed their teeth. But in any case, it's given us this opportunity to really impact the world in a dramatic way, and I really do go to the employees at Qualcomm, and I say, we ship, for example, last quarter over 170 million chipsets. So if you have an idea that goes into a chip, in 3 months you can impact 170 million plus people's lives, which is an incredible opportunity. It's an incredible responsibility too. And so you heard, we're very focused on using this technology for enabling a lot of different things in the world for social benefit, healthcare and education and public safety and entrepreneurship and governance and just all sorts of projects along those lines. And that is something that I think I learned that here, to care about the broader world and to make sure that the benefits that we have, we are using those for social good. And anyway, so being able to be part of that's been an amazing journey for me. So I thought maybe the best way to sort of frame this speech was to kind of go back and just talk about the evolution of our vision in Qualcomm. And I try and run the company by articulating a vision that then other people can figure out inside the company how their particular projects sort of align with that vision. And that way I don't have to, in a top-down way, say, you do this, you do that, because we have very smart people. They don't really want to be told all the time what to do. But if you say, hey, we're all heading off in this direction, and then people come up with their own ideas, and that's actually caused us to be quite flexible, very opportunistic. And so anyway, so leading with a vision is really the way that I try and run the company. And the first vision really was simple. The company launched without any products in mind. It was people who knew how to do digital communications theory. And what had happened at a previous company that they had been at was computation was somewhat expensive. And so the previous company, we used digital communications theory for military and space applications because you could pay for the computation there. And so there was things like, sending back, photographs from deep space probes and doing various radio links. And towards the end of that company, we did some commercial applications. We did digital satellite TV. We did small aperture terminals for, you go to the gas station and put your credit card in, and it would use the VSAT to send the information back and forth and do the authorization. So we did that kind of stuff in the previous company. I say we. I was just a summer student back at the time, but I still feel like I was part of it. Anyways, the thing that happened at Qualcomm was that computation became cheap, and so it was cheap enough to use for commercial and consumer applications. And the first thing that we did, first major project we did, was a satellite system for sending messages to long-haul trucks, which we actually recently just sold this business. And within the last 6 months, we sold that business. It's still going strong. A lot of it is now run over terrestrial data networks because cellular is so proliferated so much, but there's still a satellite component to it. Interesting thing that we did there, by the way, was all of our competitors thought that you had to launch dedicated satellites to do mobile satellite systems, and our engineers figured out how to build a system that would work within the existing TV transponder. So you can imagine our costs were dramatically less to launch the system. The performance was extremely good, and that's why basically 25 years later that product still is the market leader. But in any case, so that was our first vision. It was really not about any product whatsoever. The next vision was we were talking about doing a satellite system using CDMA technology. And with satellites, you don't really have the near-far problem, which I suspect many of you know, and I won't go into great detail. But anyway, there's a particular problem about how close the transmitters and receivers are and whether you can overwhelm the signal. Someone can overwhelm the signal of somebody else. And my father and another guy were driving down the freeway in Los Angeles, and I guess they passed a cell site. And the cellular industry was trying to figure out how to get more capacity. This was back when they had analog cellular systems. They realized they could use CDMA to solve that problem and get this 10x capacity increase that the industry wanted. But as you might imagine, there were countervailing forces in the industry. We were an upstart. There were existing large companies in there. They didn't want us playing in this space, and so that was a very long battle. Some called it the Holy War back then. And when I took over in 2005 as CEO, there were still echoes of that war still in terms of our relationships. In fact, quite strong echoes, and it was one of the first things that I had to deal with as CEO was to go out and heal some of those wounds. But basically, we were a company that was just focused. CDMA was our mantra. We were going to go cause that to be the technology, and I think maybe Shankar would even tell you. I said even back then that this was going to be the technology that the world would use. I didn't quite realize it was going to be so big, but we just believed. We believed in our hearts, our souls that was the technology, and it took that to make the company win. But what we also recognized early on was, hey, we had built a data system, and my first job at Qualcomm was building the speech compression algorithm. And to me, the radio was the pipe. It had certain characteristics to it, but I saw it as a thing that connected the applications on the end. In this case, the applications were, speech encoder and speech decoder, and we were just sending digital data across the system, which is totally, everybody gets that now, but back then that was semi-interesting, semi-radical. But what we realized then was that this was a data carrying system, and we had a guy there who then figured out how to build an underlying layer such that we could run the internet protocols across that. So in the very early 90s, we had put the internet protocols into cell phones. Now, the wireless operators had no idea why you were doing that. At best, you were using a dial-up modem to get to AOL or something like that, so they made us make it look like a dial-up modem. So we put a little application on the phone that took the commands, and we put a modem bank in the network that made the noises. And later on, next year, we just pulled all of that stuff off, slapped a browser on one side, and directly connected into the internet on the other. And so we believed really strongly in this notion of the mobile internet. And I used to go around telling people, wireless internet greater than wired internet. And I think today that's actually the case. We've surpassed the wired internet. More people have access over phones now than over PCs, and that's a pretty cool thing to have been part of. But once you believe that you have that, then you start thinking about, okay, what's the next thing to do? And it came to us that all these different devices were going to be put into the phone. And I used to come up and we'd have these big arguments about, is Wi-Fi going to kill cellular? Is the phone going to disrupt the PC? All of these different arguments. I'd go to Silicon Valley, and I'd almost get rotten tomatoes thrown at me because people just got so angry about this notion. And the other thing that happened was we started putting more features in the phone, and people kept saying to us, I make phone calls on this thing. Why are you putting GPS in there? Why am I downloading software into this thing? But we came up with the idea that we wanted the phone to be the most personal device. And today that's obvious to you. But I tell you, before the iPhone came out and really popularized that notion, most people didn't believe in it. And in the late 90s, when I had that Palm smartphone, I was sitting on a beach in Maui, and I used the Alta Vista search engine, if you remember that one, to typed in Maui sushi and found the best sushi restaurant in Maui. And I realized, connected devices, it was all over for an unconnected device. Everything was going to be connected. So we really put a ton of effort in that. We went from being a radio company to being a company that does microprocessors and graphics and connectivity of all styles, multimedia capabilities. All of this stuff got built into the phone, which you see as obvious now. But the result was we helped get that wave started, but we were sitting in the right position when the wave hit. And so the kind of growth rates that we've had, 20, 30% kind of growth rates over the last few years have been because we were in the right place with those kinds of technologies. And all of these things that I'm talking about, they continue on. We still do these things, although I would say, CDMA less than just any kind of wireless technology. But when I was talking about this most personal device, the phone as your device for entertainment and computing and productivity, everybody gets that today because I suspect there isn't anybody here who doesn't have a smartphone. Anybody without a smartphone? Okay, you can leave now. No, I'm sorry. I will try and convince you that you need a smartphone. How's that? No, seriously though, once you once you have this, everybody in the industry is doing it. So our thing is we don't want to be commoditized. We've got to think of the next new thing. And so the next new thing, I believe, is this notion of a digital sixth sense. And so what is the digital sixth sense? Well, it's this idea, okay, we have our supposedly five senses, but we all know that we live in a world that's not just the physical world around us. It's very obvious to us, right? We all have a digital life. We have a presence in cyberspace. And not only that, but there is virtual cyber information, digital information that's associated with the real world that we're in. We just don't perceive it directly. And it's natural to us that we carry our phones around. I mean, nobody argues about facts in the bar anymore. You just pull out your phone and Google whatever it was, right? So you have this sense that you have access to the cyber world, that you have a portal to the cyber world, but it's not necessarily connected to the place that you're in. And so the idea in the future, I believe, is that we will blur the lines between cyberspace and real space. And you will stop thinking about there being a bright line between those two things. And the phone and other devices will be the things that cause that line to be blurred for you, to the point where we will augment reality. And we were having discussions early on today about interfaces between your brain and electronics. Those are farther out than what I'm talking about, but those are sort of in the directions of things that I fundamentally believe will happen over time, and I'll talk to you a little bit more about that. But you can imagine that you have an augmentation of your ability to perceive digital things that are going on, virtual things that are going on in your home, whether it's content that's arrived that you want to have access to, status of the house, the appliances, the doors locked, unlocked, the lights on, where the kids are, where the pets are. All these kinds of things that might be going on in your house. In your office, obviously, similar kinds of things. I want to know who's in the meeting, if I'm distributing content to each other, if I'm getting information about my business, how it's running, getting alerts on things, stuff that might have to do with a place that I walk into. Or even out and about. I go into a store, the store not necessarily knows me. We're building technologies that will anonymize you, but if you choose to let the store know it's you, they might give you something. If you choose to let the store know that I'm somebody who's interested in this, they could give you something. If you say, I don't want them to know I'm here, drop the bits on the floor. They have no idea that you even came through the store. But the notion that you might go into a retail establishment and get stuff. I'm lucky enough to be part of the group that bought the Sacramento Kings, and we're going to build a new arena in Sacramento. And this thing is going to be completely connected. I mean, we're talking about getting megabits per second per seat. We're talking about being able to walk through the environment and have offers and information sent to you. We're talking about finding out where your friends are naturally in the environment, and doing this at the scale of that kind of concentration of people. They're knowing what's going on, knowing what's hot, knowing what people are looking at, knowing what's where your friends are or like-minded people are, all these kinds of things. You want to be able to sense those things that are information, but you want to sense them directly. And so that's really this notion of the digital sixth sense. And so we already have the precursors to this in the phone, because the phones today have an awful lot of stuff in them. They have lots of sensors. They have GPS sensors in them, so they know your location. But not only outdoors, we're building technologies so that you sense the location very accurately indoors as well. And we were just talking about ultrasound sensors today that will actually even sense, very well how you're moving your body around and so forth. So very, very accurate sensors about location. You have lots of capabilities in there, accelerometers and gyroscopes and all sorts of stuff to sense your motion. So people are building, all these activity trackers and kinds of things like that. A thing that will actually, these incredible camera technologies in there. And the camera technologies today are basically, normal 2D kind of cameras, but the ones in the future are going to be camera arrays that will capture three-dimensional information as well. And the picture that's up here is actually a thing that we showed. It's an augmented reality game, which basically the game field is set up by, you put stuff down on your coffee table, the tablet digitizes the table in the 3D and then builds the game surface around it. So if you have a stack of books, that becomes a fort that some of the characters play out of. If you have a vase, it becomes a mountain that they can climb up, and so on and so forth. So these devices will be interpreting the environment, and they will register virtual objects onto the real environment. And that technology is quite good now, and the capabilities inside the devices, the computation and the sensing technologies allow that to work very well. And so, this notion of walking down the street in a foreign country, being able to image a sign that you can't read, have it translated for you, and then become clickable, all of these kinds of things are now feasible. And another thing that's happened more recently is that people have started to build phones that just sit there and listen for you to say a keyword. So you don't actually have to unlock the screen and turn things on. You just talk to it, and it'll do searches for you. But there's other things that we're doing with just listening to the ambient acoustic environment, and we use that to actually tell when people are in the same room with each other. And in fact, it even works across a telephone line. So if you have these kind of technologies running, I can tell when somebody on the other side of the link leaves the room, if they are willing to share that information with me. But we can get that kind of information just by ambient sensing. And so this notion of these sensors being on and keeping track of the context and the environment that we're in is something that is built into the phones and is going to get better and better as time goes on. And what will happen is that we'll actually move from the way that we interact with our phones today, which I would say is kind of episodic, although lots of episodes. 150 times a day people touch their phones on average, to something that's really a continuous interaction model. And so we built this watch that has an always-on screen, and the watch very low power consumption. You charge it once, lasts for 5 days. It's hooked to my phone over Bluetooth, and so, for example, here I can get I can see things like incoming phone calls. I can get calendar appointments. I can pull information off, whether it's stock quotes. This is pretty interesting. I'll talk a little bit more about it, but I can get information from other devices captured through the phone and pushed up to the device. This is a pulse oximeter that's giving information. Google Maps, for example, sends alerts on to your phone, and when you have it out and you're looking at it, that's one thing. But if I'm outdoors and I can't read the screen, it can actually push the next direction. So I go somewhere and it tells me, okay, the next thing you need to do is such and such, pushes that to the watch. Sports information too. So I have USA Today and New York Times hooked up to this. So I was having lunch with the chancellor and we found out that there was a deal on the budget. That was kind of a good thing. But those kinds of things come to you, and they can notify you at all times, and you say, well, that will be a pain in the rear to get all these notifications, except for the fact that it's right here, and so all I have to do, if I'm interested, I look at it. If I'm not interested, I just do that and I flick it away. And so this idea that you will be able to interact with the cyber world all the time, because notifications will come to you of stuff that's around, and it won't be annoying to you because it's very easy to get rid of if you're not interested in it, but it will allow you to know in cases when you are interested that, okay, now you can do something. And another component that's really important as part of this vision of digital sixth sense is that everything around us is going to be connected. And of course, in this building, there's lots of sensors and all sorts of things that are connected up to the net, and you can interface with them. But when I talk to most audiences, I just tell them, look, the projections are that by 2020 there'll be 25 billion connected devices, and only half of those will be handsets. So the other half of those will be other stuff. And a lot of that other stuff is sensors and input-output devices and all sorts of things in the world around us that we will be able to interact with. And you can see various kinds of things on the slide. But basically what's happened is that we've spent so much money driving the cost down and the performance up of the capabilities that have gone into the smartphone chips, that all those devices that came into the phone, now the phone is going out to all those devices around us. And so whether it's the fact that every car now is going to be a connected car, that they'll all have some connection into the network, and there's lots of things that the car companies do with it, and there's lots of services that you can get from it. I mean, it's bizarre to me that, at Qualcomm we're talking to white goods manufacturers. So people are building connectivity into washing machines so that they can alert, instead of buzzing, it can send a notification here or to my phone or to the TV screen that I'm watching on. The refrigerator can tell me whether the refrigerator door has been left open by my kids, or the freezer door, so things don't melt. We're talking about applying these technologies to all sorts of screens, because obviously that's a wonderful thing. If I can walk in to a room and on an ad hoc basis say I'm going to use this projector, I'm going to use this screen. But other things, the music systems are all being connected up. The game consoles are all being connected up. People, obviously, the fact that you can walk into a room and us as people, to the extent that we are willing to share the information with each other, we will in the future know, here's the set of people that are in the room with me, here's the information that they're willing to share with me, and we'll go back and forth. And of course, if you don't want to participate, you don't participate. But if you want to, you can be known, or you can be known to a subset of people. So the notion that we will actually identify and form ad hoc groups with each other and authorize each other because we're in the same physical space, that will happen. A great example is when I get in the car with my phone will recognize the car's there, and it says you can use the microphone, the speakers, the displays, here's how you lock and unlock the doors, and so forth. But in the future, my friend will get in the car, and my friend will also then be authorized to use those things. Now, of course, when my friend gets out of the car, I don't necessarily want him using the microphones and eavesdropping on me. So you want to be able to, on an ad hoc basis, say, yes, you have authorization to use these devices, no, you don't. And that will all come about by these various technologies that we're building into the phone and into these other things. Objects, so light switches, speakers, thermostats, light bulbs. I mean, these things are already happening. You see this stuff happening. It's not happening in a coordinated fashion yet. It's happening sort of in a distributed, siloed, but we have a way of bringing that stuff together, which I'll talk about. And then, of course, as I said already, places. I talked about the Sacramento Arena is going to have this, fabulous connectivity capability. But your house, the store that you go to, all these kinds of places are going to be very connected. And what will happen then is that the phone will sit in the middle of this big environment. We had this discussion today about this Swarm OS. It's really this notion of connecting up to services that are available in the world around you. And so the notion, like I said, of input and output devices, that I might bring my device with me and just on an ad hoc basis have access to a keyboard and screens and motion sensors and cameras and all sorts of stuff. So sensors also, or I might, for a healthcare application, there will be sensors, scales, and other kinds of monitors to check my health. Another cool thing that will happen is that we'll actually offload computation because it will be cheaper to ship the information over to a device that's plugged into the wall and has more power than the phone that I'm carrying with me, do the computation there and ship the results back than it will be to do it right on the phone itself. And then also we are doing wireless power. So this watch actually charges wirelessly. I don't plug anything into it. And in the future, that will be true of your phone. Your phone you'll put it down on a table. There'll be wireless charging capability built into the room or into the table, and your stuff will recharge that way. So you'll have access now to resources that are available in the world around you. And one of the things I think that will be very interesting is just this notion of distributing storage as well, because the idea that I might actually physically transport bits seems bizarre to you. But in fact, I can get higher bandwidth by carrying bits around physically than I can through almost any other means of transportation. The latency is bad, but the bandwidth can be extraordinarily high. And so the notion in some places where you want to conserve the over-the-air bandwidth, you may push stuff out to caches, and then the phone will upload and download as it goes through, and you'll upload and download to people nearby you, and that's how we will sort of spread information in places where certain resources are very expensive and other resources are cheaper. So the devices will, on an ad hoc basis, tap into these resources that are around us. So basically, this digital sixth sense will give us this notion of information that's that's around us in the world around us. And so this idea that I will know the state of things that are nearby, and I talked already about this idea that it will capture information about me, my personal state. It will capture information about the physical location that I'm in. It will capture information about the people who are coming into that location with me to the extent that they're willing to share with me. But the thing that I'm really excited about is the use of this for healthcare. And look, I run a business, so mobile is about a $1.5 trillion business. Healthcare is a $6.5 trillion business. So, it shouldn't cost that much for one thing. There's not enough of it. A bunch of us, many people in developing countries, we're having what's called the age wave. So people are aging, and the doctors aren't going to be there there won't be enough doctors to take care of everybody. So we got to get productivity up. We got to get costs down. And I think, one of the things we look at is how do we go and disrupt healthcare by coming at it from a continuously connected point of view. And I think many of you work in these areas. You get the notion. This thing that's on the screen right now is sort of a first pass of what we've been doing. It's basically a hub system that medical devices generally have some kind of communications capability in them. But they don't rev that very often. We try to put cellular connectivity into many of these things, but the problem is that you have to go through both an FDA regulatory cycle and an FCC regulatory cycle, and that didn't match up. So what we did was we just built a hub that these different devices can talk to, and then on the back end it goes into a database that's all HIPAA compliant and so forth, so privacy is respected. But if you want, that information now can be delivered. Instead of being siloed one manufacturer at a time, that can be delivered and mashed up and goes to you, to your family, to your healthcare provider, to your insurer if you decide to do that. And we've put it both in a standalone device so that somebody comes home from the hospital, they have their medical device and this hub, they just plug it in the wall and everything just works. But we also now have ported it into the phone, and so these medical devices talk to the phone, and the phone keeps track. And there's a lot of local computation that gets done, because you can imagine you put all these sensors out there, they can overwhelm the network. And so some local computation gets done. In other cases, data just flows directly through, depending on what the regulatory requirements are. But that system now allows information there. So if I'm wearing a continuous glucometer on my waist, and my blood glucose level goes up or down, I can immediately get information here. You say, okay, that's kind of interesting. But I actually think it'll go far beyond that, that you'll have sensors inside your body. Pacemakers that are lower mortality rates by 50% by being connected. But even more, we're doing a clinical trial right now of a sensor that's intended to be injected into your bloodstream. And what happens is when you're about to have a heart attack, cells start to die, and the DNA and various biomarkers start flowing through your body, and you can actually detect that 2 weeks ahead of time. That's what we're looking for. So imagine your phone rings and tells you that 2 weeks from now you're going to have a heart attack. Which is actually a good thing, because you can do something about it and not have your heart muscle die. So, yeah, if you get voicemail, that's why you want to get it in real time. So seriously, though, there will be stuff that you will agree to put inside your body to monitor your health. That will happen. And you can see that example right there is one that many people can relate to. And I think it's something that will go on even more in the future. Another thing that we did to try and drive this vision, trying to create sort of a catalyzing effect where mobile health went from being something that's sort of science fiction to being reality, and we actually worked with the XPRIZE Foundation, which hopefully you guys know. The XPRIZE, the first one was launching the Virgin something or other thing up twice into low Earth, not orbit, but suborbital. Anyway, so we did an XPRIZE with them on the tricorder, and so the idea is that there's 40 teams now that are competing to build a device that's 5 pounds or less that can diagnose 15 disease states equal to or better than a panel of board-certified physicians. And the competition is going to happen in basically 3+ years from now, and I personally think it's going to get won. And this will be a device that uses sensor technologies that are being created, both invasive and non-invasive, preferentially, the less invasive, the better. It's going to use various kinds of, software systems for decision support and diagnosis. It'll use back-end systems, communication systems. So the idea is that in developed worlds, you won't necessarily send people to the emergency room because they'll be able to figure stuff out themselves. And in developing worlds, you can use less skilled healthcare professionals to go out and use this to do initial diagnosis and see whether people need to actually go for more care. And so the early days of this stuff is already happening. We see some of these things happening, but by doing this prize, and it's a $10 million prize, we thought, okay, we're going to really catalyze people, and we're going to make this a reality. And so the tricorder that we all saw in Star Trek, I think in 3.5 years, we're going to have a tricorder. Okay, the other thing for this notion of the Internet of Everything is obviously connecting everything together. So we have all sorts of radios, cellular radios and Wi-Fi and Bluetooth and Zigbee and this. I mean, there's just, there's a broad range of them. But what we want to do is make sure that we can connect up these things as much as possible so they can actually interact with each other. But what's really important is not just the fact that they can have radio communications with each other, but we want them to be able to connect to each other. And one of the problems with the Internet of Everything and machine-to-machine communications is often these different devices are built by companies that specialize in a particular vertical. And so they're sitting in their own silo. And even in the same companies, you see that the guys that work on energy systems and displays, they're not talking to each other. They're far apart in their companies. And you can say the same thing about many, many other things. So we wanted to create a system that actually talked across all these verticals, a horizontal layer. And it's an open source project called AllJoin. In fact, the Linux Foundation today and tomorrow is running a session with a bunch of companies that have come in from all sorts of areas. I mean, like I said, white goods manufacturers and consumer electronics guys, and obviously communications and automotive and energy, and just broad ranges of companies coming in to talk about how we create some layer that cuts across all of these. And what the layer does is it allows for discovery, it allows for control, it allows for notifications, allows for ad hoc authentication. So it allows you to do these different kinds of mashups of stuff. And we did the initial work because we wanted this to be out there just to cause sort of the tide to rise, so that the Internet of Everything can actually work and these various things can all talk to each other. But we made it an open source project because we didn't want anybody saying, oh, well, now Qualcomm's going to come in and try and tightly control this thing. So it's a Linux Foundation effort. I encourage you to go check it out. It's pretty cool stuff, and there's people here who are already working on this notion. And one of the things that's cool also is that there's a framework on the phone such that if you build an AllJoin capable device, it can actually send notifications and controls to the watch. So I can control stuff from the watch, which is kind of cool. The other thing, obviously, is these sensors are going to create tremendous amounts of big data. And so the notion that you'll want to be able to, analyze that data and do things that people want at the time, the right information at the right place at the right time. And that, in this picture, we're talking about retail, but I just talked about healthcare. It's the same notion. You want to be able to look at that information that's coming in. You want to be able to compress that down. You've got to care about the power consumption of these sensors. You've got to care about the network load of these sensors. But still, a lot of information is going to get crunched, whether it's crunched at the edges or crunched in some centralized places. Both will happen. But the notion that we will actually have a lot more information about the world around us, I think, is probably pretty natural to this audience. But that will become a much, much more mainstream concept in the next few years. And one of the things that we did with this, actually, we built a system that uses the sensors in the phones. And this is actually an image of an app that we did for Paramount for the Star Trek Into Darkness movie, where you ran an app on the phone, and it had various sensors. It detected when you were watching a certain video. It detected when you went to a certain place. It detected when you saw a certain poster. And as you went around and did these missions and went certain places, you unlocked more content. And it was very, very highly downloaded. Another thing that we've done is that we've worked with some of the biggest ad agencies in Japan, and they've actually used this system and found that once you give information that is localized and personalized, then they were getting 3 times better click-through rates on information because it actually was something that people cared about. And then beyond this, beyond what's in the phone, we've actually built a system of very inexpensive Bluetooth beacons that beacon out rolling codes. So if I carry one of these around, I'm sending out a beacon, but not a beacon that can be traced to me because the codes roll all the time. And it's only after I give my authorization that then I can go back and correlate that sequence of codes was this person. And if I say, up to this time you can know it's me, but after that you can, as soon as the code rolls, nobody knows who I am anymore. So we did it to make sure that we could preserve anonymity and still get the benefits that you get of saying, okay, if I'm willing to say who I am, I can get this offer. If I'm not willing to say who I am, but I'm willing to say I'm interested in X, I can get that offer. And if I'm willing not to do anything at all, just drop the bits on the floor and nobody knows I was there. And this came from the time when we worked and put GPS into the phone, and people said, oh, it'll be great, the restaurant will know when you walk by to send you an alert. And I said, I don't want the restaurant knowing all the time that I'm walking around the city, that I'm right next to them, so that they can send me an alert. And so this is the response to that. At very, very low power, very low cost, we can beacon out information. The phone walks through, and it gets the information, and it can respond how you as the user decide to respond. And if it's a notification, it comes here. And if I'm not interested in it, I just flick it away. So it's it's less than a second for me to deal with these kinds of things. And of course, with machine learning over time, you'll filter better and better, or you'll do things right off the bat to filter. So a lot of really interesting things going on. We're actually doing a trial with the Dolphins in Sun Life Stadium, where you'll walk through the stadium. When you come in, various things will happen. When you leave the stadium after the game, it will actually give you information about traffic conditions and any other information about the game that you might be interested in, obviously offers to go various places and so forth. So this stuff's actually rolling out now, and it's real, and it's very, very inexpensive to use these technologies because the sensor was built into the phone, and the phone was the expensive component that made it all work. And then, so finally, I was saying earlier, we'll have this seamless interactivity. We'll have the device on our wrist. We'll have the alerts, but we'll also have the controls. So here, this is an AllJoin alarm that says, I'm an alarm in the room. Do you want to control me, turn me on, turn me off, set the time, whatever it is, turn the lights on and off? And there's, these are not the real user interfaces, obviously. But anyway, so, you can hit the button, on, off, dim, whatever. Coffee pods. We actually showed these things off at trade shows, and they're kind of fun because everybody walks up and they sort of play with all the devices in the world around them. But the notion is that I don't have to pull my phone out of my pocket, unlock the screen, bring up the app and do it. Stuff will actually get pushed to you in real time. So interactivity will happen in a far, far more seamless way. And so you can imagine now this notion of being able to see things around you, interact with things around you that are virtual things, but you'll actually have the notifications coming to you in a very seamless fashion. And so in the end, we're really focused on what's the evolution of all of these different technologies. How do we drive new radios, new services, new processors, new devices that are out in the world, new protocol layers? I mean, it's, from top to bottom, there are new opportunities to do things once you think about the world in a way where the physical world and the cyber world are combined together, and they're seamless between each other. And so that's the vision that we're working on right now. I think it's been exciting for us. We've already started to do a lot of things along those lines. And like I said, because it's a vision that I articulated to the company, I'm not the one that's coming up with every single idea. I don't have to push things down. People in the company come up with all sorts of crazy sorts of interesting ideas. So hopefully you will too. Thanks.
Let's see, since we're being webcast, let me request you to use microphones. So Karen has one, and Jane has the other. And I think I've been told to give preference to the students.
In the back. Doug?
To people who are going to ask hard questions.
Well, I hope I can ask some hard ones here. So
All right.
you have...
Identify yourself.
So my name's Douglas Hutchings. I'm an undergraduate here, and I actually work with one of the groups that put this event on.
Thank you.
Glad to be of service. So you articulate an idea about, okay, I'm going to have this digital connectivity everywhere, but not only a small portion of the world actually has access to a phone or access to some other digital communication or technology and infrastructure to understand how to use it and possess it. Do you view that as part of Qualcomm's responsibility to sort of make that more accessible, or do you think technology is going to get there, it will get there and I don't have to deal with that?
Nope, it's our responsibility to drive the cost down in the devices and to build networks in various systems that allow us to get connectivity to the most remote places that we can possibly get it to. So we're working on all sorts of technologies to do that. We're working on things to make the use of the technology not just on the device side, but actually generating the bits over the air radically cheaper. We have an effort called the 1000x challenge, which is to increase the bandwidth by 1,000 times and reduce the cost by 1,000 times. And we pretty much know how we're going to do that. So the network will be massively decentralized, very, very inexpensive, and it will be able to do things like download content, be edges of a content distribution system. But the thing that I was talking about earlier about this notion of physically carrying bits around, that's a thing that I think will get used in emerging markets dramatically, so that the expensive part of getting from the cloud, the big network, to a device in an area, that'll happen once and be shared among many people, and then it will actually be distributed by super distribution. People will distribute to each other, and sort of that's how content will go out in the world. And that will radically decrease the cost, and it will radically increase the coverage. But we're also building peer-to-peer networks too, so that if you're in an area where you don't have macro network coverage, you'll still be able to communicate with devices and send information back and forth. And so all these different techniques will allow us to give connectivity where maybe you wouldn't have had it normally. And then there's satellite systems that are getting built. I mean, there's just a broad range of things that are going on. But we absolutely feel like it's our responsibility.
Hi, my name is Maggie. I'm one of the probably few business majors in this room. Everyone else is engineering. It's kind of intimidating.
Thanks for being here.
Well, I have to say thank you for the very fascinating presentation. My parents both work at Qualcomm, and I can tell you they do not give me that much insight. So my question
they're
is...
doing their job. They're being very secret. No, actually, we're not that secretive, actually.
Actually, I didn't know they were engineers until I was in high school, but they're pretty secretive. So my question is, it's fascinating how this kind of technology can put us into almost an alternate perspective or reality. My question is, how does that have implications on our humanity and our reliance for technology? I know that's a really big question.
You really don't want me to tell you the answer to that. Okay, so there's sort of the near-term aspects of it of just people relating to each other. And I know that there's a lot of people who think that we're using these devices and being less connected to each other, but I don't believe that's true. I find that using the devices actually allows me to be connected to people that are far away in space. And it allows also the sense that it's a sense of security. So it's not that I'm talking to my friends and family and colleagues all the time, but the fact that I have a phone and they have a phone, I'm not worried. I know that my son, who's off traveling in Europe right now, I can get in touch with him anytime I want. And in fact, I can have a face-to-face video conference with him whenever I want. And so that gives me a sense of security. And by the way, that applies to healthcare too. In the future, you won't think that your doctor's watching you at all time, but the fact that somebody can watch you in case something happens will give you that sense of security. So I think those notions of enhancing our ability to interact with each other, I think, are incredible. And there's some amazing examples of things that happen. Look at the Arab Spring, where people were posting pictures on Facebook of snipers on rooftops, so people knew, don't go there. It's not safe to go there. Go somewhere else, or they can organize and create social change. All of these kinds of things have created amazing, amazing opportunities for human expression and so forth. In the long term, I think we need to watch to make sure that privacy is is maintained. Now, maybe that's a generational thing that I care more about privacy than people who've grown up in an age of massive social networking. But I don't know. I mean, it takes an Edward Snowden event to make people think about it, and so those kinds of things, privacy and security, I think those things will be things that we all care about. And so there are upsides. There are always with any technology some downsides, and we need I think it's a Berkeley thing actually that we should be caring about what those downsides might be and trying to mitigate them and avoid them as much as possible and focus on using these technologies for social benefit.
Hi, Dr. Jacobs. I'm John Doddelin. I'm a junior in the Material Science and Engineering Department. I was wondering what your thoughts are on the role of artificial intelligence in the bioinformatics predictive medicine side of what you guys are doing. It's something I'm very personally interested in.
Yeah, no, it's a huge thing because, the tricorder XPRIZE is all about artificial intelligence and bioinformatics and using sensors to do this kind of work. Because if you think about it, you take your average doctor, they've been trained a certain way, but they clearly don't know everything. And even more importantly, as time goes on, medicine is increasingly personalized, so that there are drugs that are specifically targeted to a particular mutation of a cancer cell that you have, and then you peel the onion back, and all of that stuff is done through bioinformatics at this point, and the ability to do sequencing is getting cheaper and cheaper and cheaper, and at some point, that's going to be a plug-in on your cell phone maybe, or at least an accessory that you might have, and so I think those components are absolutely critical going forward. And the artificial intelligence systems are getting better and better. I was telling some of the people earlier, we have a technology we just announced called Zeroth, which is new processor architecture, which is spiking neuron model. So it's modeled after the way your brain works, and the thing does unbelievable stuff. You don't program it, you teach it. And it already today does tracking of objects better than dedicated algorithms because it can deal with different backgrounds, occlusions, objects that are very similar looking to each other, moving at high speed with other stuff coming across, and it keeps track of all that kind of stuff. And we can do various motion control systems with it already. So that notion of artificial intelligence, which is different from a lot of traditional artificial intelligence, I think that's going to be quite an interesting field going into the future, and we're building, software tools and so forth for people to experiment with that as well. So there's sort of the more traditional kind of AI, and then there's this new, new. That's probably the wrong way to say it, but it's this notion of using biomimicry to build real systems that do, sensing and interpretation, and kind of like robots for your mind as opposed to, robots for your body. That stuff's happening.
By the way, Paul has promised his good offices to help us get his CTO, Matt Grove, to talk about Zero. It's exciting news, by the way, as he said it. So it's neuromorphic computing. It's really fabulous.
It really works. It's a little frightening, actually, that it works so well. It's very biological looking. So.
Hi, Dr. Jacobs. My name's PJ. I'm a grad student in
PJ. That's good.
Oh, yeah, I'm a grad student in the translational medicine program, and I did my undergrad at UCSD.
Cool.
And your family's been a huge benefactor there as well, so thank you very much. My question is, since you spent so much time here at Berkeley, I was wondering what your favorite memory of Cal is.
Very good.
You mean aside from getting out? Actually, I can tell you my best memory actually was quite early on. I met my wife in the first week of school in the dorms, and we stayed together through Cal, and 30-something years. But anyways, it's my brother played beach volleyball in La Jolla, and so I was only okay at volleyball, but when you come to college, nobody really knows that. So I just went around to all the pretty girls I could find and tried to get them on my volleyball team. And then I found the two ugliest guys in the dorm This is being web. Sorry, guys. One of them's nickname was Bear because he was so hairy, and so. Anyways, that's how I ended up with my wife.
All right, good. Kathy.
Hi, my name is Kathy Wu, and I'm a first-year PhD student in the EECS department. So I wanted to say that privacy is a growing concern, and I'm really happy about the comments you said about privacy. Along the same lines, I wanted to ask you about security. So especially with entering the healthcare industry, especially with devices in actual human bodies, I was wondering what your view is on how to provide guarantees on safety and security of these devices, because it's a growing concern.
Guarantees are hard when it comes to security of systems, but I would argue the systems aren't secure in that sense even today. So the issue is actually us putting more emphasis on, already today in medical systems you have to put redundancy and like things like the different processors running completely different code and voting and all sorts of stuff to make sure that the systems work. And I think we just need to put more and more emphasis on that. And the fact that they'll be upgradable, so there will be cat and mouse kind of attackers versus defenders going on all the time in all of these systems. I mean, I talk about this Internet of Everything. I mean, once you start building things into buildings and the built environment, they're going to be there for a long time, so they better be upgradable, and you're going to have to deal with security. And obviously, healthcare is an area that you care an awful lot about. But like I said, I mean, today pacemakers are connected, and you get tremendous benefits from it. I mean, 50% reduction in mortality rates and so forth by being connected. So there's a trade-off. And I think if somebody wants to do something bad, it's if they decide that they're going to kill you by messing with your pacemaker, that's because they're already a psychopath. And so we've got to deal with those people and try and create societies where people don't do that. I mean, those kinds of issues are incredibly serious, and we put a lot of effort into it. And we're actually building technologies now to try and sort of be monitors, so they'll sit, trusted computing, things that will sit aside and watch what's going on in the system and try and detect things that are happening based on the behaviors and not necessarily based on finding this particular bit of code that we've already detected as being a virus and or malware and so forth. So I think there are a lot of techniques. Of course, every defensive technique, somebody's going to come up with the next way around it, and so I mean, it's just cat and mouse, and we're going to have to deal with that.
Last question.
I see.
Hello, Dr. Jacobs.
Make it good.
Thank you so much for coming.
No pressure.
I'm sorry.
He said make it good, so
okay.
Just trying to give you a little more pressure.
I think it's good, but we'll see. So my name is Krishna Parashar. I'm a second-year computer science major here. One of the questions that I had throughout the presentation was, with the exception of healthcare, it seems like these technologies are being used to solve first-world problems. That's things that we face in America or privileged countries. But how can we harness these technologies to solve problems like poverty or agriculture, education, all the problems that majority of the world faces?
Yep, that's a great question.
Thank you.
Okay, so first of all, I mean, one of the things that we're doing is just trying to get the cost down. So drive cost out of it so that more and more people around the world have access to these technologies. And we're doing a pretty good job so far. There's projected to be 7 billion smartphones sold between 2012 and 2017. More than half of those will go into what we'll call emerging markets. And then the question is, what do you do with those? So we already have projects underway where we do things like Egypt. We have a teledermatology project where people can use the camera on the cell phone, take a picture of a skin lesion, send it back. Doctors they analyze it, they send back the information, say, okay, here's what you have to go do. We did agricultural projects. We had this fishing with 3G nets thing where people get information, the fishermen get information on weather conditions, where the fish are. Once they catch the fish, they get information on which market to go to so that they don't all go to the same place, drive the cost down or the prices down. And that's actually been demonstrated to have returns. We're doing education things. We did a number of projects. Actually, John, you did a project on teaching people English, and so we did an algebra thing. Actually, that was in the U.S., but it's applicable, where you give kids the ability to actually teach each other how to solve the problems, and we got massive increases in standardized test scores. So education, entrepreneurship. We have a project we did with a professor at UCSD around voting fraud. So there's actually patterns that you can detect when fraud is occurring in a voting place, so they could actually go in and figure out which voting places were fraudulent and deal with that. So doing governance kinds of issues. I mean, we have a project or a program called Wireless Reach, which does these kinds of projects for social benefits around the world. And I don't know, the number is escaping me, but I think it's 200 projects or something like that in 40 countries. I probably got the number wrong, but it's a large number of projects around the world. And it's actually, we do it because it motivates the employees tremendously. I mean, people want to know that they're part of something bigger than themselves, and that they create this amazing technology sitting in, half of them sit in beautiful San Diego. I mean, yeah, we have people all over the world, but the notion that you can take the advantage that you have and create opportunity for other people is, it's just a very motivating thing. I think it's a lesson we all learn from being in Berkeley, that we're part of a bigger world, and so using these technologies, driving the costs down as much as possible, working with partners who are in these markets so that we actually know what the needs of that market are, instead of trying to use our first world notions to create solutions for that. And then the other thing that's very interesting, it's kind of like the boomerang effect, is that some of the technologies that we created for emerging markets, like how do you build a $20 cell phone? Well, once you build the chip that will make a $20 cell phone for sale in India, that chip can come back to the United States and be something that goes into a wireless glucometer or some, the boomerang effect happens, that developing solutions for price-sensitive markets actually is important as a way to get technologies back into the United States. And I would say on mobile health, it's absolutely the case today that more mobile health work is being done outside the United States because of the regulatory burden of the United States and of many developed countries. You're seeing a lot of stuff going on in the Middle East and Southeast Asia and Latin America and Africa. I mean, you see all this stuff happening because it can happen in those places. There aren't as much entrenched interests and so forth. So yeah, we see that as a huge responsibility of the company.
Paul, I know you didn't talk about this, but to this question, financial inclusion, letting people use cell phones to be, in terms of developing world, letting people, and this is part of this boomerang story. So, and that's the reason why Rajiv Shah says what he does. I think, in addition to these, it's also the infrastructure for getting people to get money.
People they have connectivity and they have an amazing amount of compute capability. Even in the lowest end cell phone, you have an amazing amount of compute capability that you are now proliferating around for very inexpensive amounts of money. Yeah, it's a lot of money relative to the income levels, but you actually find people prioritize communications above many other things in their lives. And there's a reason, because it improves their economic condition, and then they can live a better life. And we've seen that already happen. I mean, there are studies that show, based off of some of these programs, that people's economic condition and their standard of living goes up. And so that's why we're excited about being part of what we say is humanity's biggest platform, because it does allow you to have impacts in all walks of life, all areas of life.
He did make a good question, I'd say.
That was a good question. That was a great question.
Paul, this has been a fascinating afternoon with you. As we always knew it would be. Two little things. On behalf of Berkeley, on behalf of the university, we'd like to present you with a small remembrance of today's event. It's a rugby shirt.
Go Bears.
Many thanks to you. This concludes today's Regents Lecture. Please join me in thanking Paul for joining us today. I'd like to thank our co-sponsors. I missed the SWE folks who are out here, and the PI folks. The program will be on the Berkeley Engineering YouTube channel early next week, and I hope you'll join us in the atrium, in the Kwame Atrium, for the reception. Go Bears!
Go Bears.